Hello everyone, welcome to our expert webinar on serverless computing infrastructure for data analytics. I am Siddharth from Spring People and I'll be your moderator for today's session. Spring People is India's largest enterprise training provider. Today's session will be conducted by Mr. Rajiv Chandran. He comes with more than 20 years of extensive experience in building high-performance solutions in data and web space. So without further ado, we'll go ahead with today's session. Over to you, Mr. Rajiv.
Thank you, Siddharth. Hello all, good evening. Welcome to this webinar on serverless computing infrastructure for data analytics. Yeah, I presume you might have had a brush with this particular subject in some form or the other if you are coming from the data analytics side of it. So yes, I'll roughly spend around 45 minutes going through this slide and taking you through the various technology, the various stacks that are available all across the cloud, or one you could build on your own. And then at the end of the session, I'll take some Q&A from if you have any questions, queries regarding this. Okay, so I'm sure all of us have come across this term serverless computing. But before that, there was other things as well. However, the idea of virtualization existed even much before that in the mainframe systems which IBM had built. But this got into a different, different kinds of technology as it got evolved into various ways as it evolved. So, starting with a physical systems that which is what everybody is aware, we moved into understanding what was this virtual machines all about. And I said the prominence of which came because of having virtual machines on Intel architecture, but otherwise it existed in other architectures much before Intel as such. And then this idea of containerization, which came towards the mid of 2000s. Again, this also existed previously before it actually became popular. And finally, this idea of serverless. I mean, honestly, serverless is something that everybody was been working around indirectly, but they gave it a brand name and that made it even more better to work with. But there's much more than that when we talk about this idea called serverless. So each of these systems has their own timelines to deploy. Yeah, some like the physical deployment takes it in months, while the virtual, as you were all aware of, could take even just minutes to spin up, and while containers take even lesser time. While serverless is as simple as saying that it's like sitting on your desktop and starting a process. It's as simple as that, right? This kind of a feel when you have it in cloud and have this across for bigger platforms is where that makes so much of a difference. So that's a broad idea of how this whole technology has evolved. The compute side of the technology has evolved. What is serverless? It's basically in the simplest form, like how I would write a code in my laptop. Either you may package it or you may not package it, or it's a single file, and then you just start it. So if I had an environment like that, if I had an environment where I could run my process, I can have my data stored in that way and access it. So that would be the simplest form, because I don't have to worry about my whole, I don't have to worry about my infra in any form. All that I'm worried about is I write my code, whether it's going to be stable, and can I scale as my load increases. Rest everything else are taken care by somebody, some provider. So that's the kind of computing infra I would love to have. Now, this definitely existed in the web world, right? So in the web, the idea of microservices helped us, as you would rightly know, to evolve faster coding, going to market in a quicker way, less maintenance, and overall less cost. Now, this idea of microservices, when we want to extend that into data, right? That's where the whole savings come around, right? Now, we are all used to having a web infra, various forms of web, 3-tier, 4-tier, etc. And each tier has its own compute workload styles through which we work. While the backend, which is where the data lies, that was always not in a microservices way, right? It was always a monolithic form, in any way you looked at it. Now, this idea of microservices extending into data platforms is where this whole new way of computing is coming around, when we look at the modern need of getting into AI and various stuffs that comes into the picture. So this is where it's making the difference when we are looking at how the idea of data in a serverless space or a microservices way of looking at it. Why microservice? Why serverless? And how is it different uh, when compared to when compared to other forms of computing? So as we rightly understand, by default the management is low, right? Because the provider manages everything for you, literally everything, except that you worry on the code side of it. And in today's context, uh, see, it's becoming even more difficult to get skilled people on the data side of it, on the data space. See, earlier, the data and its stack was always complex, as you would know if you have managed any kind of a database systems or a data warehouse systems. It's always been complex, and it's very much expensive as well. So you always needed specialized people with completely different skills to manage it compared to the traditional managing a platform like a Linux or systems as such. So now, in a scenario like that, is there a way we could completely avoid that operation cost, the license cost, the setup time, etc.? Now, that would be a huge saving if you actually get into that space, right? And that's what serverless computing is getting into for the data. And more importantly, now it's it's a perennial problem on how to scale the backend systems. When I talk of backend, I'm talking of the databases, right? How do we scale that? Can we see? It's always easy to scale a front end system where there are APIs. It just takes seconds to scale up. But now that was not easy with respect to any database kind of any backend systems where you hold data. It was always you could vertically scale, which was kind of easy, but again that scaling was always with a downtime. It was never there was never a real time scaling. Without a downtime you couldn't scale. So now with the serverless computing, uh, with the serverless computing for data, you get that dynamic scaling. You don't have to manage anything. And most importantly, what you notice in contrasting to the web infra, for a data. The workload characteristics for data, it's not continuous. It could be in bursts or it could be in batches, but the overall percentage of real time or a 20 or kind of a 24 up run services is really not required to a large extent. That may be 15-20% of the overall solution. So that way, contrasting again to the web infra, which had to be up 24/7, we need not. So there is space for us to shut down and utilize many of the data services, unless and otherwise you are doing some real-time analytics. But that's a very small percentage of the overall solution you compare. So this gives, with serverless, it gives that idea of pay as much as you consume and nothing more. And we are talking of infra, which is really huge. So we just look at that, how that infra and how they have virtualized or made it serverless for each of those layers. So just looking at a bit of analytical history. So we had this period between 70s is where that whole idea of the relational RDBMS concepts come up, and then IBM and Oracle get into that. So between 70 and 2000, that's the era of whole idea of these data warehousing, the monolithic systems, largely about batch processing. There was really no real-time processing, and then you create reports based on that. And compute-wise, what is important to know is these were all statistically related analytics, or descriptive analytics. At best, you get into inferential statistics, but that again was in a small proportion. So come the era of 2000, I think Yahoo started around 1994 and Google started in 97. So that's the start of those era of the big data, right? Now that period between this 2000 and 2010 is where this whole idea of unstructured and semi-structured data getting into this space, contrasting that to a structured, ordered data that you would find in your relational system. Now, this explosion largely related with largely related with the web-related stuffs, and the usage of web usage of web in many forms for anything. It's starting with the e-com platforms to search to the social media. I mean, that's the stage, right? That's the time where all of these companies, starting from your Facebooks and LinkedIn's and of course the Amazons had already started by then, and various other organizations step in, and, and that brings the idea of big data. So why I'm contrasting here? Because this era and the data generated in this era was finding it difficult to be ported onto the stack of the 70s to 2000 era, and they had to build something different, and we'll come to that. Likewise, the step so it was also the era of machine learning stuff. So when I use the word machine learning, it's largely about um, uh, the concept of predictive analytics, whereas the other one was descriptive. Here it is predictive, and when I say predictive, it's about not using deep learning, but using every algorithm around machine learning and all those analytics that you could use for understanding the user, and then making it to in like So some of the best, like Netflixes and Amazon, on trying to understand how the search patterns are, and then helping them a better giving better recommendation to those kind of searches and things like that. So those were the analytics, the algorithms that stepped into this whole idea of machine learning, and it helped. It helped. So the reason, see, the idea of the machine learning existed way back in the 50s and 60s, but nobody had no systems had the compute power to actually utilize them. So that's why they largely fell back on statistical and inferential statistics to help predict, compared to using machine learning, which actually gave a better way of looking at things. And fast forward to the present. mm, the whole idea of using mobile for everything, and the whole idea of this sensor-based tools have changed the whole mechanics of how the data is to be handled, stored, processed in a different way. So this is the era where the idea of deep learning sets in, right? It's around it's around this time, the two big products which come into the market. One is the way to write distributed application. I must admit, Hadoop was there in the mid to 2000s, but yes, it did better. But the biggest change was brought by this tool called Apache Spark and TensorFlow, which brought in the idea of deep learning, that the analytics for which you needed uh, better compute power. It is just not better compute power. You need actually the whole CPU itself changes into GPU and TPU. You are using tensors largely there to do the compute. So that brings about a whole bit of change. The whole idea of storing, processing, real-time analytics, all of that change. Now, in this space, I'm saying I want to introduce the idea of serverless analytics. Yeah, so it is in this space. I'm saying, how would you bring in the idea of serverless computing to do deep learning? And that's what I want to show up in the rest of the slides, and the technology stack behind it, and how do you bring up that solution. Okay, so just to refer back into our reminiscing our old platforms. So yeah, on the left is how a traditional data warehouse looked like. They were monolithic systems. When I use the word monolithic, it largely means I can scale it vertically, but not horizontally. That's why, and it's in that context I'm using that word. So as I said, that all existed up to the 2000s. Yeah, the Hadoop as a platform only just comes around 2006, but prior to that, the idea of a distributed platform for storing data and computing it uh, probably existed in Google, using that MapReduce paper which was released. So people, so organizations from this particular space moved towards this in the probably around in the late in the late 2000s. Yeah, that's where when it actually got popular. It was so. What is important here to know? Here, the processing structured data, vertically scaling, and statistical, as I said, largely processing. Come here, we are talking of structured data, semi-structured data, though you could have unstructured as well, but processing was not, and we processed largely for both yeah, predictive, descriptive, and predictive modeling. Uh, yeah, the biggest, though a great platform, I should say, but the biggest drawback has been the number of moving components. It had so many moving components. Sometimes, to build a platform like this, it took months. You probably needed to buy hundreds of servers. Largely, if you take any of the Hadoop platforms, they are minimum around 200, 300 systems, and they are, by that word, non-shared architecture. They are all non-shared architecture. So to build something in the non-shared architecture, and then having the data stored, and then how do you share it, how do you process it? Yeah, it was a very, very complex. It normally took a year to build a platform, um, a platform like this. So we still have these platforms, rather, people, the organization who still want to have on-prem presence, have these kind of architectures still existing. They are doing some, they are going through a transformation phase, but we will see them what they are. They continue to have it, but you need to have a big a set of team to kind of work on these kind of platforms. Now, how did that whole simplify? How did that get simplified? Now, these architecture moved into the cloud, right? So, uh, that came as the biggest way of enabling quicker realization of value for your data. However, you still had to push your data from whatever sources into the cloud. Now you could provision these infra, that same infra that you see here in the Hadoop, uh, with, I mean, in days, not even months. And okay, we could do this in days, and then you had various ways to. So here, if you had only one form of storing the data, you had multiple options to store it here, and then you had you of course had multiple ways to store and process it as well, either through a bash or I mean a batch or a script or an SQL and things like that. And now we've moved from we continue to have the traditional statistical analytic. That's not going to go away anyway, but we would also have the machine learning way of looking at things, and finally the AI way of looking at things. So you had to build this infra, this whole infra, in a serverless fashion, where you could bring this up in minutes, contrary to the earlier way of having, if it's normal physical, it would take months to do it, or here or in a cloud where you could even take you would take around days to complete this whole solution. Okay, so what do organization want to save on their time for develop for time to solution it, and less on the cost? They want this everything in an API fashion. So can we have that? Can we have? So you see that there are three layers every platform has. There's an ETL, there's a serving, there's a data store, and then there's a way to access. So largely, any of these analytical platform will have this layer, and it actually comes from this whole the original data warehouse of this ETL and processing, and then the visualization of the serving layer, as you would want to call it. Now, I would want all of those layers to be connected via API and nothing more. So that's the platform that we have today uh, to run your analytics. And what analytics are we talking about? Descriptive, predictive, cognitive. All the three applications in a serverless way, just using APIs, we could build it up. So we could build this on-prem using the set of tools that are available using open source, or the other easy way, which companies normally start. If you're starting off, they would prefer to have this built on the cloud, and then later, based on the way complexity and cost and support, they would have some portions make it on. So if it's in cloud, it's just about you would have a UI, and then have the whole stuff run. So it's as simple as that. Just and you'll have your storage. You'll have your solution ready for analytics. And this is how largely what it would look like. So you would have a storage layer, and that's built on various technologies, right? We would have a distributed computing layer, and there are 2-3 choices for them. And then we would have a layer for a single UI. Though, yeah, I mean, I've pointed out 3 different ways of looking at it, but you would just have a single UI through which I could run my my descriptive analytics, my predictive analytics, and my cognitive analytics, all with just a click of a button. So this whole infra that you're looking here is uh, is what is created through this serverless architecture. Um, uh, um, Rather, the components mentioned are what is going into that systems for creating this whole architecture. Now, this is how the stack could look like. Okay, so we get this idea called so the earlier storage was HDFS, and prior to that, it was just nothing but a relational database, or maybe a non-relational database was the way of storing data. Here the idea of storing becomes what is called as a data lake. Now, what is a data lake? It's where disparate can dump data from data sources, consume it. You catalog them. You through an RBAC, a role-based access control kind of a model. You have safely processed. Otherwise, you get into a lot of issues, right? So uh, the stack, what you see here, is built around with these technologies. So there is a lake house. Today, we don't even call it data lake, we call it lake house. That's your storage platform. And it could be built with Hadoop. Or you could, if it's in cloud, it's kind of built with any of their object-based storages. It could be even built with block-based storages. It could be anything, basically. But people tend to use object-based storages largely just because of the cost, angle. So you have a lakehouse, and then you have a compute layer. Now, compute layer is, I mean, that's the crux, right? Now, what's important about the compute layer? The compute layer must be able to do it in a distributed fashion, right? It should be able to do in a distributed fashion. Otherwise, we've lost the scalability factor, right? So it should be able to do in a distributed fashion. It should support your traditional analytics, which I say is your descriptive. It should support your machine learning. It should support your cognitive. When I use the word cognitive here, it is largely talking about unstructured data, things like the best example to speak of. You have live streaming of the IPL happening, and in that streaming, do you want to process anything? right? You want to add anything, you want to see yeah, I mean, as the stream comes, do you want to take a judgment? I mean, do you want to, through an AI, do you think you need to insert an ad? So uh, so uh, so it should do that side of it, right? Both batch and stream. So all of that, I would, as a data scientist or a data analyst or a data engineer, I just want to do that from a single UI. Okay. So for that, you have many kind of UIs, and probably you might have heard of this word called Jupyter, or Zeppelin, or if you're using today, there are other stacks that are coming like Databricks and Snowflakes, and they have their own unified UI. Now, if you are using a unified UI and you're able to process all of them, it's I mean, I use this word called you know, local processing and local scaling. So now, what's the problem of, you can run any analytics within your laptop, right? But can you scale it? That's the problem, right? So with a serverless technology platform, you are actually able to write it locally and experience that scaling locally itself. So that's the greatest advantage which the serverless platform gives you. And what's more important, you are still using it when you want to use it. As I said, data's workload characteristics are largely batch and less of real time. So you switch off when you don't need it, and you bring that back when you want to have it. So at a minimalistic level, if you want to build something, say in your organization, all that you need to have is a Kubernetes cluster, uh, a Spark cluster, and a Presto cluster. Now, why these three things? Your Kubernetes creates that serverless framework, right? The Kubernetes creates the serverless framework for you. Spark creates the distributed analytical platform based on Kubernetes. Okay, and Presto gives you that SQL, distributed SQL on top of Spark. Now, today, if you look at the analytical space, people continue to use your SQL as the main processing tool. All right. So it's not gone away. Though large people thought it may go away, but it hasn't. It's actually becoming more dominant. And today you would see. I mean, yeah, you would see sometimes. The SQL was traditionally used to do your statistical analytics, your mean, mode, median, standard variation, standard deviation, correlations, etc., and do some inferential analytics based on your probability and things like that, right? Uh, Now, to do a predictive analytics, example, say, can I write an SQL query to predict what is going to be my sales for this store for this day, etc. So we haven't reached that level, but we are closely being there using SQL, right? So SQL is going to be there. Why? SQL is going to be there. We still need a language API layer, which again Spark is. So Spark gives you the option of writing your analytics, right? Whether it's pure code or with a mix and match through your Python. Largely, that's what seems to be the language which people do, or Scala, and sometimes people do it in Java as well. So a combination of this is the serverless computing, data computing platform, basically built with these three tools. However, uh, as you rightly know, there is much more than that. You also need to have your data lakes and other things, and the whole supporting framework, right? Though it's not shown here, you need to have your whole supporting way of governance and integration and security and various other things which will go as a part of this particular framework. Right? So that's the backend to it. Now, so the slide basically tell you is like if you want to build something of a full stack on the cloud or on-prem, these are the basic things that you would need. You would need your lake house, the whole idea of this, which is built on your HDFS, or if it's on AWS, you use an S3 or an Azure blob and a Google Liquid. Now, all this going completely serverless. So that means it's just you click a few buttons and then it's ready. So I need to have my serverless lake house. I need to have my serverless ETL jobs. So as you would know, the data, if it is not streamed, if it is elsewhere, then they need to be brought into the analytical framework, into the analytical stack to be, and while you are pumping in, you do the ETL side, and I want to do that serverless. Now you have uh, today's sensors and other tools for real-time analytics, right? Video streaming, and you want to identify if that given image pose uh, uh, pose any alert for whatever reasons maybe, then you need to have real-time process, right? Whether it's your descriptive, predictive, or cognitive. And the whole serverless data engineering, which is the Spark. And the SQL. So between Presto and Spark, it gives you the whole framework for designing your descriptive, predictive, and cognitive analytics. Spark is actually a single tool that has everything in that. It has SQL, it has its machine learning, it has its API, it has everything. But there are some drawbacks because of which we tend to use tools like Presto and things like that. And I can make that serverless. And then today you have these notebooks largely for building up whatever it could be, a predictive model that you want to build or a normal descriptive model. So a UI for that, and that goes serverless again. And finally the dashboards, right? So I mean, the dashboards would be as simple as opening up your browser, giving the link, and the dashboard should be there, ready. So if you could actually build this stack up, you have built a full stack serverless data platform, and this is what is already available through different technology stack in the three other clouds, that which is the prominent ones, along with the two other exclusive to analytics, which is Databricks and Snowflake. Okay, so now that we saw so much on the stack. So now let's look at on the cloud, and what are the tools that are available on the cloud that help you to go serverless, right? So now I talked about this framework, Kubernetes with Spark and Presto. So the equivalent stuff um, uh, you want to you would want to have. So I'm just talking of the Kubernetes, but Spark and Presto can be added to that. Is if you're talking of your serverless framework in AWS, it's the Fargate, right? Equivalent than on Google, it's called the Cloud Run, and on Azure it is the container. So as I said, it's all that you do as a developer is write your code, either you containerize it through Docker or you zip it as a file, right? If you're going to containerize it as a Docker, then you run it on this platform. If you zip it as a file, then you run it here. how do they differ? So these in the function mode, they are nothing but, I mean, as a solution, they're nothing but basic, your cron jobs, nothing more than that. They are, and you could run it, else you could have this. You can do this in couple of ways that way. Then now going ETL for your going serverless for your ETL. Now there are again, so if you are going on-prem, then you have tools like, yeah, if it's otherwise on cloud, you have your AWS Glue or your Azure Data Factory and the data. So this will help you to. So when I'm saying serverless ETL, all that there are two ways to look at it. In certain spaces, you may have to write a bit of your code, or in other ways, you just do a click and run, because large part of the coding, the solution itself might have provided. So to move in this data, all you need is these tools, and largely they will run with click of your button. Likewise, if you, as an example, so if you are just looking at a batch processing in the cloud, if you had a file, you would push it into your an S3 through an ETL. Then you do through you would take a function, process, and then have that kind of so that's the kind of stuff that you would want to see if you can do with just click of a button. Likewise, you can do the streaming as well in a very similar way, and you have set of tools for doing the same stuff. Okay, now distribute SQL. So this is a very interesting piece which a lot of people tend to use. So as I said, the whole idea of a distributed SQL is running an SQL query across multiple nodes, and the and so the biggest, I mean, both the tool called Spark and Presto does that in different ways. Basically, these tools, Athena, AWS Athena, and Synapse is basically built off Presto. And what's good about them? They don't worry about where the data stood, as you could use a front end of SQL and then query it and get whatever that you want. So you could build, so you could do interactive SQL just roughly running. So example, you could say, yeah, you want to see how many Swiggy deliveries are there to be distributed, to be completed in the next 10 minutes, and I can run a quick interactive query and or if you had some real-time processing, you could see that in the dashboarding side of it. And of course, you can create these things. But the important piece is this is all about distributed SQL. Okay, now this is what today a lot of people want to know how it is actually. Now, as I told you, SQL is the way of doing your standard predictive, descriptive, the descriptive analytics. But you want to do something in the predictive and in the cognitive space, then I need I need another set of tools to bring a solution there. So today, probably building this is the most complex piece in this whole serverless architecture. Today, with a single UI like a SageMaker, I can do my data prep, I can do my modeling, I can simulation test and deploy it. And as I said, local coding and local scaling without even have to worry about the infra side of it. So this is the clincher among all the tools. Today, many of the organizations have a single UI which interfaces both the SQL side of it and the machine learning and the cognitive side of it. So this is gone virtual, and Now, what's the advantage? So now you can see, imagine the most complex data analytic processes are doing something in the machine learning and the AI. Now, imagine the kind of servers that you need. You need your GPUs or your TPUs, the algorithms that are needed. Now, here, what this saying is, write your code. Just yeah, you could even containerize it or don't containerize it, and then run it, and you get the same thing which you would have otherwise needed a complex infrastructure to solution. Likewise, the dashboarding itself is become serverless. So as I said, in the dashboarding world, I mean, many of you might be quite aware of the Power BI and QuickSight, or there's also Tableau and things like that, or the open source version, which is quite popular, the superset. All you need is you just give a link, and your whole dashboard appears. So the backend, the backend process to do this, to help you give those images, they are again of distributed, and you don't have to worry about the computing infrastructure behind to get this whole nice UI that you're seeing. There is this complete solution that is built for it to give you these whole UI. Okay, so um, finally coming to the last part of this whole the whole webinar, what are lake houses? Okay, so the lake house is a bridge, or it's a combination of a data warehouse and a data lake. Now, what was good about data warehouse? The good part of data warehouse is everything was structured. I could use my SQL, and see, honestly, for whatever said and done, you still need processed, structured data to do good analytics, and that's not going to go away, right? The Hadoop, when it came in, yeah, it allowed us to store and process, but the structure in the data made it complicated to run process unless you write a lot amount of code, and that's not feasible with a lot of the data engineers and the data scientists, right? They would want to have clean code, use it, and stuff. So that continues, that need continues, and your data warehouse was the classic example to you, while the data lake provided that scalability, petabytes of data, right, which you couldn't hold it in your data lakes, sorry, in your data warehouse. So combining these properties is what we call lake houses. So today, this whole idea of lake house is also gone serverless, right? And it's largely presently in the big cloud organizations. Rather, I should be saying the other two which I talked about, Databricks and Snowflake, they probably are sitting on one of these clouds. Now, this whole solution of the lake house is actually gone serverless. So that way, if you look at it, starting from yes, looking at this picture, my storage, my compute, my UI, and my operations all have gone serverless with with these infrastructure and the software solutions that have come. Okay, so that's about it on this whole big picture of serverless data compute platforms. Hope it helped to give you some understanding, and maybe you want to take this and try in one of the clouds, and to unify this whole process of interactive streaming, and both for predictive and cognitive, and otherwise descriptive as well. Siddharth, so you want to add something, and then I'll take up the query.
Please put up the courses slide next on the screen. Yeah. So thank you, Rajiv, for your valuable insights. So I'm sure the participants would have found the session highly informative. If you guys are interested in leveraging more about our courses, so you can just go check our website, and the courses names are listed here. These trainings can be leveraged online from the comfort of your home and are flexible to suit schedule and location. We can also schedule private training batches for interested candidates. So for further info, do write to us at training@springpeople.com or call on the number displayed in the current slide. Now we shall jump to the Q&A session where Rajiv will answer your questions. So over to you, Rajiv.
Yeah, hi, thanks, Siddharth. I'll just there are a few queries that I've seen here. Okay, what are the drawbacks? I think because Malvi asked, what are the drawbacks of serverless? Yeah, I mean, to think of on the serverless, everything is good, except that yeah, it's all available only on the public cloud. You want to build that something locally is where the carry. Otherwise, it's a perfect solution. There are hardly any drawbacks if you integrate it well. So very limited drawbacks if there are any. Rather, I have not seen if there is any drawback. It's just going to be on the integration side, but the clouds have done that very well and um, trying to do that in the on-premise where it's going to be the and yeah, okay. So yeah, Priyanka had a question on what is vertical scaling. So this idea of vertical scaling and horizontal scaling, Priyanka. So uh, take your desktop, take your laptop, and imagine it has 8 cores or 10 cores, whatever, and you want to run up your program. It can maximum consume 8 cores within that. And if you want to say you want to make it more, you want to make this application more powerful, then you will have to physically add CPUs within your desktop to move from say 8 or 10 to 12. That's vertical scale. Horizontal scaling means it's just like having multiple desktop given to you, and you can use all of the desktop CPU to run the process. That's the difference. And when will we choose serverless computing over container? Because both, I mean, yeah, the serverless is a brand name rather. Actually, the technology behind that is containers. It's a nice way of masking it, honestly. So there's no difference. They are one and the same. And how will the microservices? Okay, so to deploy today microservices microservices has been the a pioneer in taking up the serverless side of it. All that you do today is create. So if you write in Scala or Python, just make a container of it, and then go to any of the cloud solutions providers. Now it's AWS, you have Fargate, and if it's Google, you have Cloud Run. Plug your container, run it. And what's good about it, so if your container may say presently, if your container is running on a single CPU with maybe 1 or 2 GB RAM, and you think that is sufficient, that's fine. If you want to scale it and say I want 10 CPUs and say 32 GB, you can just seamlessly expand with just a click of a button. It is so seamless. So the scalability is happening in milliseconds here, not even in seconds. It's that flexible. Is on-prem distributed data platform? Yeah, actually yes. So anything and everything is built on Kubernetes. Though we don't yeah, you don't get much picture about that. uh, Everything, when you hear the word serverless and container, it's Kubernetes. If it is serverless and then you hear the word functions, it could be containers, or it could be just a plain cron job. But largely I see the organizations are using the word are using containers again in that, but they're hiding it away. Like if I take AWS there, which I tend to use more, they kind of minimize the amount of time you can process with the function. So functions largely means I just take a file and write some code and run. Thanks. What should be the strategy to build search distributed hybrid? So again, yeah. So So how I would start? Imagine if it's a startup, I would first build this on-prem, and then today, on the cloud, using all those tools that I showed you. Once you're matured and then you want to cost optimize and various things, today what happens is all these cloud providers give you tools to go on-prem. I can basically trying to tie you up with these guys. So all that you need to do is build up a distributed platform, basically, like I said, either through a Hadoop based approach or through an object storage based approach, using Kubernetes and Spark and things like, and move the data between the clouds through any of those connecting uh, softwares, like, yeah, if it's an AWS data pipeline or a data factory. So they all have these tools to connect and then scale. But the other interesting which I think is not happened is, can I say, if I spin up, so if I want to have a distributed processing, where some containers are on-prem and then some containers are in cloud, and they all form a single computing for our data. Yeah, that's not happened yet, but that would be sooner than later, as I think. How efficient to use a product of one platform? Yeah, it is, but the efficiency comes, right? The efficiency comes uh, uh, with having the serverless mode of things. Okay, I think that's all the questions as well. Yeah,
Okay. So thank you, Rajiv. Thank you for answering the questions. So I'd just like to thank everyone for joining us here today. Recording of the session shall be mailed to everyone, even those who have not attended yet. We hope to see you at our future tech webinars as well. Uh, this is Siddharth signing off on behalf of Spring People. Bye bye.